Hi, and welcome back. Last time we talked about variables and something called an assignment statement. And we saw that we can
Wait, didn't I
assign
just
a
watch this?
name to a
This doesn't actually break it down. Oh, shit. In a program anywhere a literal value or string number is acceptable or more complicated expression is also acceptable. I don't understand what this means. Maybe I should watch this video.
value. But it would be pretty boring if all we could have on the right hand side of an assignment statement was a single value. Instead, Python allows us to do some very interesting calculations on that right hand side, and then the result of those calculations are stored as a value and named by a variable. The calculations on the right-hand side of that uh, assignment
Can't see
statement are
shit.
called expressions. So let's look at a couple of examples of expressions, and these should look pretty familiar to you. They're fairly standard mathematical things. So 1 plus 1,
Oh,
for
okay.
example, or 2 times 2. Notice how that we write the multiplication symbol, or even something a little more complex using one of the built-in functions of Python. We can find out the length of a string called Luther. So those are all expressions, and of course you can make them as complex as you want in terms of mathematics. You can combine multiplication and addition and subtraction and so forth, and you can use parentheses to group things and make sure that you're
What are my
getting
classes?
the order.
Got myself a kitty. That.
Prop. Proper. So since these are expressions, we can use them on the right-hand side of an assignment statement. So here's a couple of examples here in this box. We can assign minutes to a simple value. Notice in this line, not only can we use a value in an expression, but we can also substitute in another variable for use in an expression. And so we can make use of one result in the next line. before we finally print out the result. Okay, so expressions are composed of both operators and operands. So let's look at
The fuck's an
some
operand?
of the operators that we have. As I said, we have the standard mathematical operators: plus, minus. Again, multiplication is done with the asterisk character, and divide is done with the forward slash character. If we want to take an exponent, we use two asterisks right together with no space. So if we wanted to find out what 10 squared was, we would write that 10 and then the double asterisks like that, followed by 2. Now when we're doing floating point, or I'm sorry, when we're doing division using the divide character, the standard result that Python will return when we're dividing any two numbers is a floating point number. If we want to get back an integer number as the result of a division, we use the double slash for integer division. And of course, if we're doing integer division, we might need to know what the remainder is, and so for that we can use this modulus operator to find what the remainder is. All right, this remainder operator is very useful in a lot of different circumstances. One of the most common times that you might want to use something like that you would want to use the remainder operator might be if you want to determine if a number is even, for example. And so you could take some number, we'll call that my number, because again, we might have assigned anything to that. Mod, we say, or to use the modulus operator, mod 2. And if this expression returns 0, if the remainder is 0, then we know that the number is even. Okay, so the book goes through a number of examples, but let's finish out this short section by focusing on this particular example in CodeLens here. So we'll start out.
Oh wait, this is supposed to be the book.
By assigning the total seconds. All right, suppose that you had a seconds only stopwatch and you came up with 7,684 seconds and you wanted to figure out how many hours, minutes, and seconds that really was. We'd start out by assigning that value to the variable total seconds. Now if we want to find out how many hours that is, we can take the total number of seconds and use integer division to divide by 3,600, which is the number of seconds in an hour. So that tells us the number of hours. And again, we used integer division here because hours only are whole numbers. How many seconds are still remaining? Then we take the total number of seconds that we started with, and we use the modulo operator, again by 3,600, to find out what's the remainder. All right, so let's step through this step. So we find out that it's 2 hours, and when we use the remainder, we see that there are still 484 seconds remaining. Okay, so that's less than an hour, but it's certainly some number of minutes. So we want to figure out the number of minutes here by stepping through another integer division. We take the seconds that are still remaining and divide by the number of seconds in a minute. And when we do that, we find out that that's 8 minutes totally left. And then
I know I should be able to focus on what the fuck it's actually saying, but I can't because I'm just so pissed off that I can't actually see what's on the screen because the fucking
seconds still remaining modulo 60 and see what we get, and we find out that we have
resolution is dog shit.
Seconds finally remaining. So that 7,684 seconds was 2 hours, 8 minutes, and 4 seconds. All right, so that shows you how you can combine variables into expressions, how you can make one expression depend on the result of an expression that is, or of a statement that's happened on a previous line of your program. We've seen how you can use variables in the expression, and we've seen some examples now of using regular mathematical operators and integer operators. And as we move on in the course, you'll see that there are a number of other operators that we haven't covered here today that we can apply to strings, and we can apply to some other.
Man. Okay. Huh. What's separated by comma? Why can't I save it on this one? I don't understand. Holy shit.
With a function call, it's even possible to have a complex expression before the left parenthesis, as long as that expression evaluates to a function object. For now, though, we will just use variable names, like square, sub, and len, that are directly bound to function objects. It is important to start learning to read code that contains complex expressions. The Python interpreter examines any line of code and parses it into components. For example, if it sees an equals symbol, it will try to treat the whole line as an assignment statement. It will expect to see a valid variable name to the left of the equals, and will parse everything to the right of the equals as an expression. It will try to figure out whether the right side is a literal, a variable name, an operator expression, or a function call expression. If it's an operator expression, it will further try to parse the sub-expressions before and after the operator. And so on. You should learn to parse lines of code in the same way. In order to evaluate an operator expression, the Python interpreter first completely evaluates the expression before the operator, then the one after, then combines the two resulting values using the operator. In order to evaluate a function call expression, the interpreter evaluates the expression before the parentheses, i.e., it looks up the name of the function. Then it tries to evaluate each of the expressions inside the parentheses. There may be more than one, separated by commas. The values of those expressions are passed as inputs to the function when the function is called. If a function call expression is a sub-expression of some more complicated expression, as square x is in sub square y square x, then the return value from square x is passed as an input to the subfunction. This is one of the tricky things that you will have to get used to working out when you read or write code. In this example, the square function is called twice before the subfunction is called, even though the subfunction comes first when reading the code from left to right. In the following example, we will use the notation of add to indicate that Python has looked up the name add and determined that it is a function object.
Oh, okay. Oh, fuck me. Get the square function, a variable. Yeah. Is it? I should tell you check. Oh, I know it's too short. I want you to. Where'd it go? Oh, not look up square again. Wait, what? Look up the variable square to get the function object. Let me go back up here. Reset. It's gonna square function. So eval square is a function, so evaluates an argument. Oh, x is 2 and y is. Oh, okay. So confused right here. So it's gonna. I wish it would tell you. Square is a function, so evaluate is given. And then it's gonna look up the sub function. Right? Function object. And then it's going to try to evaluate two different things, which is going to be square and it's going to be fuck, I'm lost. I wish I could check this. And then okay, Python pivot. I don't want you to tell me. Step to look up and bold square. Okay, good. Then I need. Then I Yes, that's correct. After looking up square function, you would look up the values of variables x and y. God damn it, where is it? Oh. X 2. Oh, x plus sub. Shit. I don't think I'm doing this right anymore. then do I look up the... Alright, then do I look up the variable sub to get the function object? Up sub to get the function object. Then from sub, do I get a view of square again? And I'm gonna get look up x. And then multiply, get 4. And then I can square y? No, yeah. Oh shit, no. No, you better not have. Okay.
Minutes. 189 of your covered here.
Oh, where the fuck does this course go? Where's this video?
This, we need to look up what x. So
yeah, let me see if I'm fucking doing this shit right. It's annoying as shit. So I figure I should be watching this while doing this at the same time. Wait, is this the same thing? I'd better fucking be. Oh, I fucked this shit up hard. No, I don't, maybe not. Okay, I got the 2 for 2, right, so far.
And then before we can add x plus this expression, then we need to compute the value of this expression. So when computing the value of this expression, then we need to in turn look up the value of the sub
Okay, got that right too.
So we need to look up the variable sub to get that function object. And then we're computing of the value of its arguments. So the first argument is square of y.
So we need to look up square.
This, we need to look up what's square of what's the square function. So we look up the variable.
Yes, okay, good. I got it so far.
To get the function object.
I just got lost.
And then we need to compute the value of its argument. So we need to look up the value of y.
Oh, okay, here we go.
Look up the value of y to get 3.
That's very fucked up.
And then we back up And we need to compute the value of the second argument to sub. And in order to do that, we need to look up x again to get 2. And we need to multiply 2 by 2 to get 4.
Motherfucker. I know I'm working my way out now. I just don't. I'm so lost.
So now we have the value of both of these expressions. Oh, excuse me. There's one more thing here. So after we look up the value of variable y to get 3, we actually call the square function. So here, after we look up y to get 3, we have to run the square function. Okay, so now we have the value of this sub-expression, or this argument, and this argument. And so now we can finally call this sub-function. So we run the sub-function on inputs 4 and 9, giving us the value 5. And so then we get x plus 5. So that's going to give us 2 plus 5. And we get 7. And that means that we're calling square with 7 as an argument. And so we run the square function again on the input 7, giving us the final value of 49.
Fuck that shit. Ow, my head fucking hurts now.